Hi, in this lecture I'd like to talk about the sociology of the science management interface related to environmental management and policy. This is be through the lens of social science and policy analysts who have actually studied what basis of policy formulation and the role science has played in it. And it's an interesting perspective because it's in which we are the study subjects, we as scientists. And so it gives us some objectivity from how the process really works compared to how we, from our position, think it works. And from this, we can draw some valuable lessons to help us be more effective as scientists influencing environmental management policy. Now, I'll be covering a number of topics and some papers here that might be a little daunting at first, but this is just to set the stage. We'll come back to some of these themes and some of these perspectives throughout the semester. So the first thing I want us to think about is the various types of scientists we have with respect to their proximity to the practical use of the science that they do. So this little 2x2 contingency table here is meant to kind of suggest if we classify, if you will, scientists on the basis of the degree to which they're just out for the quest for fundamental understanding. They're driven by curiosity and the fundamental understanding of nature. To those who are actually not that interested in new understanding, they just want to apply what we know. So in these three quadrants here, we'll see Niels Bohr, a pure basic physicist, Danish physicist who helped understand a lot about the basic aspects of energy and particles, to on one end of the spectrum, high dedication to a quest for understanding, not that much focused on consideration of its use, to Thomas Edison, who was actually somewhat disdainful of scientists. He was really focusing on the practical application of science, not only for human benefit, but for profit, frankly. And then on this quadrant, on the upper right, we have Louis Pasteur, who is quite remarkable in that he made marvelous, fundamental contributions to basic understanding of microbes and life, but also was very practically oriented about the use of that knowledge for protection of human health, thus pasteurized milk to help us avoid diseases that could be transmitted. So Pasteur's quadrant is one that we all would like to, as environmental scientists, occupy from time to time, mixing our basic curiosity and our dedication to new knowledge, but also its use. This is a table that I put together some years ago that with the intent to try to help us as scientists and all the things that we have kind of focused on and value, understand that people who formulate policy aren't so much interested in those. They have very different other objectives. So for example, we value research, our publications, and they value actually outcomes, regulations, decisions. We view that it takes time to develop this information. Don't rush us. They have immediate short-term needs that need to be satisfied. We're kind of grounded on scientific evidence. They have to weigh, of course, not only the science, but human values, public opinion, economic considerations, and the like. I could go on, but the point is we have these very different cultures that we have to cross to be effective as advisors for environmental policy. This little graph was taken from a book by Kai Lee, a political scientist who's written extensively about adaptive management. So in this little conceptual diagram, on the horizontal axis, he lays out people in terms of how much they are focusing on being guided by the truth, by reason and evidence and a search for the truth. And on the vertical axis, he aligns individuals on the basis of their power and responsibility. So, we scientists, we're really focusing on the truth, but we don't have much power. We can't control, we're not responsible for the environmental outcomes, and we don't have the power to make those decisions. The layperson, of course, depending on the person, is not that much guided by truth. They're guided by emotions and the like, and they're powerless as well. So if you align these various players in the game, from a scientist to a professional analyst who might be working in an agency, for example, doing taking scientific information and bringing it to bear on the policy or management questions. An administrator could be a secretary of a state agency or something of that, who has to help formulate policy and deal directly with political leaders. We often have a concept that this relationship and this flow of information and interaction is linear, going from the scientist to the analyst to the administrator and the politician. And what we'll see is that actually this linear model very seldom is the case, and it's a much more complicated nonlinear relationship. Of course, up in the upper right, that is, individuals guided by truth, fundamentally, and also very powerful. We don't have those anymore, because this is the old notion of the philosopher king, the omniscient and wise leader who would make decisions based upon knowledge for the good of the community. So keep in mind this linear model that we'll come to reevaluate. One of the dimensions of this relationship of scientists to policymakers is revealed by work done by a political scientist by the name of Peter Haas. Now, Haas studied initially the development of the Mediterranean Action Plan, a plan to actually take steps to protect and restore the Mediterranean Sea, which was seeing some degradation. And as a political scientist, he said, these nations, these north border nations around the sea, the European nations, and then the North African nations, they'll never agree on anything. The political systemic view is that these two actors, the north-south polarization, would actually inhibit and not allow this kind of consensus and agreement on policy. On the other hand, they actually were able to achieve it. And what Haas attributed this to is to what he called an epistemic community, that is, outside of the regular political system, consisting of scientists. And the scientists, of course, from these various countries had something in common. They had scientific method. They read the same journals. They had a certain value about the role of science. So the fact that they had formed a consensus about what needed to be done meant that the political actors in those various nations were not able to overwhelm that with their own political differences, cultural differences, and that led to the adoption of the action plan. On the other hand, in the North Sea, where the science arguably was more advanced, it actually was an interaction between the environmentally more progressive states, that is Denmark, in particular Germany, and we're looking at greening their culture and their economy, to those that were less progressive. In this case, interestingly, the United Kingdom, which is an island surrounded by a lot of ocean and thought it could have dilution as the solution to their pollution. So this in fact, this dynamic was a leader-laggard relationship, much like we have actually in the Chesapeake at times, with Maryland being the leader state because we're always out and ahead of environmental policies, and we need to actually because of where we're located, and the other dragging the other states along. And the scientific consensus was less influential in that particular case. So scientists as a tribe working together can be very influential. That's his point. So this another set of views was by another political scientist named Paul Sabatier, and he looked at not only do scientists form these tribes and work together and have some power, but actually we as scientists work across the various boundaries with individuals who we share a common interest with us in the outcome. These he called advocacy coalitions, and they would include not only scientists but interest group leaders from an environmental organization, some like-minded political leaders, journalists, all kind of working together in a loose coalition to advocate a certain set of outcomes. So his point is that scientists are not neutral participants. So they're kind of separate in an ivory tower, but operate within a set of relationships where we share a certain normative assumptions, our value assumptions. So the lesson from both models is that we as scientists have professional relationships among scientists, but also these normative relationships which transcend from science to other actors within the decision-making system. So is the science, can it then be really independent? Because we have these normative views, we have bring our own value to it. Our conceptual view, and I pointed out here in red, I would suggest you read the excerpts of the Jasanoff paper that I'll be talking about here that are on the posted on Moodle, and that our traditional view is that we are just the truth, just the facts, and that we kind of live in an autonomous domain separate from these social interactions, and that we can bring facts to the table and without falling prey to the passion and irrationality that the public or political leaders. This is what she calls logical positivism, and that associates our activities with the normative commitments really designed to promote objectivity. And given what I told you about Sabace and the advocacy coalitions, Jasanoff questions whether this is really ever purely the case. And she promotes what she calls here a radical relativist view that in practice mediates this realist view that I talked about, and that we as scientists are trying to achieve a moral as well as an epistemological, that is a knowledge-based authority. And that it requires us then is thinking about that as we deal with this relationship in which we actually have to work with the political establishment in a mutually self-sustaining rather than independent position. The implications of this radical relativist view are pretty significant. We can't be expected to resolve this uncertainty which surrounds decision making on our own. But we can work with others to help repair it. Okay, if we don't know everything, how can we act based upon your desired outcomes to achieve those results? And so our scientific ideas prove influential, not because they're just objective truth, but because they converge with the prevailing cultural ideas about responsibility. They support political acceptable forms of discourse and reasoning, and are ratified by broader communities. They have the privileged right to formulate policy. Rather than the best policy, the best science, therefore, that we're all culturally trying to achieve, we should ask what is the moral certainty needed for real-time political decisions. This is a slippery slope, of course, because then we can lose our credibility by being seen as colored by advocates. And this is the position of that Roger Pielke Jr., another political scientist, reminds us of. Pielke has another 2x2 contingency in which he puts us in boxes of a pure scientist, where we have a kind of a governmental view of interest group pluralism, and where decisions are made by the majority. And this linear model that I talked about, we could say we're as a pure scientist, we just feed information up the food chain. And if you believe more of a stakeholder model that we've been talking about, then scientists can become stretched to the one extreme, become pure issue advocates. And indeed, there are scientists who work, whether they're for environmental organizations or industry, work within advocacy to try to achieve advocate for a certain outcome. If you believe that we actually work in more complex ways rather than the majority rules, you might think in the linear model of a scientific arbitrator who helps the decision makers understand the science. Pielke, though, points out that we, to be effective, need to be more honest brokers of policy alternatives that help folks think through their choices that they make, provide information relative to those choices, as well as how to achieve the chosen outcome. There are excerpts of Pielke's book on the Moodle site, but also read Jasanoff, the woman I talked about earlier, her review of Pielke. Pielke is kind of a bad boy in this political science, modern environmental policy community, because of this perspective he has. He's become quite critical of a lot of climate science. It's saying it's value-laden and that we're misleading people by exaggerating claims and so on. So you'll see on the PDF version of this, you can watch Pielke's 1-hour talk if you have some time. Fascinating lecture. So finally, we carry this forward to the whole politics of climate change now, and we have examples of scientists from all stripes, from those like Pielke, who are critics, to the extreme of Pat Michaels, who's a super critic, to Jim Hansen, who's a wild, advocating very aggressively environmental policy, to a Susan Solomon, who led the IPCC, Intergovernmental Panel on Climate Change, and had very strict rules about science and objectivity. So as we'll talk about climate change, we'll see examples of this. Thanks.